This first example is on max-min problems. Okay, so example 1, a factory produces n items per hour. The overhead costs Cn is equal to 400 minus 16n plus n squared over 4. How many items should be produced to keep the overhead costs to a minimum? Okay, so this is the function. And then if we're asked to calculate, find the many items to keep overhead costs to a minimum, we need to differentiate this function. So the first thing we're going to do is find the derivative of Cn, which is equal to, derivative of a number is just cancelled, it's gone. Derivative of minus 16n is just minus 16. And then the derivative of this here is we take the power down and reduce the power by 1. So it's going to be 2n over 4. And we can actually even just simplify that. So it's going to be minus 16 plus n over 2. Then what we need to do is, keeping overhead cost to a minimum, we need to put that equal to 0 and try to solve for n. So it's going to be n over 2 is equal to plus 16. So then we multiply by 2 on both sides, so n is equal to 32. Then we need to read the question again to make sure we've answered what we've been asked. How many items should be produced? So our answer is 32 items. Now, if it asked us to calculate the cost of the minimum number of items, I would need to sub it back into the original function, but for this example, I don't need to do that. On to example 2. So a closed rectangular box is made of thin metal. The length of the box is 3 times its width. The volume of the box is 36, and its width is x centimeters. Show that the surface area is equal to this function. That's going to be part 1. And then part 2 is find the dimensions of the box for the least surface area. So for part 1, first of all, we will draw out a diagram of what the box would look like. We know the width is x, the length is 3 times that, so that's going to be 3x, and we don't know anything about the height. Now we know the volume of the box is 36, so then we need to work that part out. We need to work out h from that. So it's going to be 3x times x times h, and that is equal to 36. So that means h is equal to 36 divided by 3x squared, which we can simplify to h is equal to 12 over x squared. And then when we're using that answer for the next part, calculate the surface area, we will leave h as 12 over x squared. So for the surface area of the box, it's going to be the length times the width by 2 plus the width times the height by 2 plus the length by the height times 2. And then we can try to simplify that down. This first part comes to 6x squared. The second part, you can see one of the x squareds in the bottom is going to cancel with the x here. So it's going to be plus 24 over x. And then the last part is going to be 2 by 3, which is 6. 6 times 12 is 72 over x. Now to simplify that fully, our answer is equal to 6x squared plus 96 over x. And that is the same as the surface area that we have to prove at the start. For the second part of the question, it said find the dimensions of the box with the least surface area. So the first thing we need to do here is differentiate. So we're going to differentiate. So it's going to be dy dx is equal to 12x squared, 12x. And now to differentiate the 96 over x part, we need to change that into 96 x to the power minus 1, and then we're going to take down the power, so it's going to be minus 96 and reduce the power by 1, so it becomes minus 2. Now if you want, you can rewrite that as 12x minus 96 over x squared, or you can just leave it as it is up above. And let's find the dimensions of the box with the least surface area, so that's the same as the minimum. We're going to put that equal to 0, and we're going to try to solve. Now putting that equal to 0, the best thing to do first of all is to multiply both sides by x squared, so we can get rid of that. So it's going to be 12x cubed minus 96 is equal to 0. And then we're going to try to factorize that. We can take so it's going to be 12x cubed is equal to 96, divide by 12 on both sides. So x cubed is equal to 8, so then x is equal to 2. So if x is equal to 2, we need to find the dimensions of the box. So the width is equal to 2 centimeters. The length is equal to 2 times 3, which is 6 centimeters. And then if the overall area, or the volume, is 36, 2 times 6 is 12, and then 12 times 3, so the height is going to be 3, and that would give me the 36. So that is the answer to that question. Now on to example 3. So a rectangle is formed by using the positive x-axis, the positive y-axis, and a point B, which is xy, on the line 2x plus y is equal to 6. Find an expression for the area, A, square units, of this rectangle in terms of x. So we need to find an expression in terms of x, first of all, for the area of this rectangle. In order to do that, I know this distance here, based on this coordinate, I know that distance is x. Based on this coordinate, I know this here length is going to be y. So to find the area is equal to xy. Now the problem is I need to get the area in terms of x only. I can use the information 2x plus y is equal to 6. I can get y on its own for this one here, so it's going to be 6 minus 2x. And then I can find the area then in terms of x only. So I'm going to change my y to 6 minus 2x. And then I multiply that out, so it's going to be 6x minus 2x squared, and that is the area in terms of x. For part 2 of the question, it said, what is the domain of the set of values of x? Now, there's two different ways of doing this. You can do it just by looking at it. Now, clearly, if you will not have a void or area of something if it is an area of 0. You can't have a rectangle if it has an area of 0. So our x values have to be x is greater than 0, and then x is less than 3. You can't possibly have any other answers to that one. Okay, so for part 3 of the question, just move this up a bit, it said, use differentiation to find the maximum possible area of this rectangle. So to find the maximum area, we need to differentiate it first of all. We're going to differentiate this function here, which is going to be 6 minus 4x, put it equal to 0, and we're going to try to solve for x. So 4x is equal to 6, so that means x is equal to 1.5, or if you prefer to write it as a fraction, you can write it as 3 over 2, and then we will sub it back into the original to get our value for the area. So it said find the maximum possible area of the rectangle. If that is what x is going to be, to find the maximum area, sub it back into the original. So it's going to be 6 bracket 3 over 2 minus 2, 3 over 2 squared. Put that in the calculator and you will get your answer, which is 4.5. Now in terms of units, we don't know it's going to be centimeters or anything, so we'll just write square units at the end. Now, generally in an exam, if you fail to write that, you would still get full marks.